What is parallel computing? Parallel computing is a form of computation in which many instructions are carried out simultaneously, operating on the principle that large problems can often be divided into smaller ones, which are solved concurrently and parallelly. Here we can see the diagram of the problem, and the instructions are divided into blocks, and these are parallel to each other, and the instructions will be sent to the CPU to solve the problem. Okay, this is meaning of parallel problem or parallel computing. Parallel computing means it is a form of computation in which many instructions are carried out simultaneously, operating on the principle that large problems can often be divided into smaller ones, which are solved concurrently. What is parallel computing? Parallel computing. The primary reasons for using parallel computing: for save time, wall clock time, solve larger problems, provide concurrency, do multiple things. Okay, here parallel computing is capable by saving the time, and it can solve a larger problems and difficulty problems, and it can do multiple. It can provide concurrency, means we can do multiple things at the same time. Other reasons might include cost savings, using multiple cheap computing resources instead of paying for the time on supercomputer, overcoming memory constraints. Single computers have very finite memory resources. For larger problems, using the memories of multiple computers may overcome the obstacle. Cost savings, using multiple cheap computing resources instead of paying for time on supercomputer, overcoming memory constraints. Single computers have very finite memory resources. For larger problems, using the memories of multiple computers may overcome this obstacle. Concepts. Von Neumann architecture. Here, um, it is consists of four main components. One is memory, control unit, arithmetic logic unit, input output device. We can see that control unit and arithmetic logic unit means we use a CPU. CPU is connected to memory unit and in vice versa, and input device goes via CPU, and output and goes to output device. If if we enter any input value, then the CPU process the control unit, and if it is an if it is any mathematical expression, so the arithmetic and logic unit will solve, and the instructions will come from memory unit, and and the output will be given. Memory is used to store both program instructions and data. Program instructions are coded data which tell the computer to do something. Data is simply information to be used by the program. Control unit fetches instructions, data from memory, decodes the instructions, and then sequentially coordinates operations to accomplish the programmed task. Arithmetic unit performs arithmetic units performs mm, arithmetic unit performs basic arithmetic operations. Input output is the interface to the human operator. Here we use the memory to store both program instructions and data. Program instructions are coded data which tell the computer to do something. Data is simply information to be used by the program. Control unit fetches instructions data from memory, decodes the instructions, and then sequentially coordinates operations to accomplish the program task. Arithmetic unit performs basic arithmetic operations. Input output is the interface to the human operator. Flynn's classical taxonomy. Flynn's classical taxonomy, we use Here we used um, SISD, SIMD, SISD, SIMD, um, MISD, MIMD. SISD means single instruction stream, single data stream. SIMD means single instruction stream, multiple data stream. MISD means multiple instruction stream, single data stream. Uh, and MIMD means multiple instruction stream, multiple data stream. Single instruction, these are four types of links. SISD means single instruction stream, single data stream. SIMD means single instruction stream, multiple data stream. MISD means multiple instruction stream, single data stream. MIMD means multiple instruction stream, multiple data stream. SISD. SISD means a serial non-parallel computer single instruction. Only one instruction stream is being acted on by CPU during any one clock cycle, single data. Only one data stream is being used as input during any one clock cycle. Deterministic execution. Single instruction multiple data. SIMD. A type of parallel computer single instruction. All the processing units execute the same instruction at given clock cycle. Multiple data. Each processing unit can operate on different data element, best suited for specialized problems, characterized by a high degree of regularity, such as graphics image processing, two varieties, processor arrays and vector pipelines. A type of parallel computer single instructions, processing units execute the same instruction at any given clock cycle. Multiple data, each processing unit can operate on different data elements, best suited for specialized problems characterized by a high degree of regularity, such as graphics images processing, two varieties, processor arrays and vector pipelines. MISD, a single data stream is fed into multiple processing units. Each processing unit operates on data independently via independent instruction streams. Some conceivable uses might be multiple frequency filters operating on a single signal stream, and multiple mm, cryptography algorithms attempting to crack a single coded message. MIMD, multiple instruction, every processor may executing a different instruction stream. Multiple data, every processor may be working with a different data stream. Execution can be synchronous or asynchronous, deterministic or non-deterministic. Parallel computer memory architectures. Shared memory, shared memory is classified into two types: uniform memory access, non-uniform memory access. Distributed memory, hybrid distributed shared memory. Shared memory. Shared memory, parallel computers have in common the ability for all processors to all memory as global and at rest space. Multiple processors can operate independently. Changes in a memory location affected by one processor are visible to other processors. Shared memories machines can be divided into two main classes based upon a memory access time, UMA and NUMA. Distributed memory. Distributed memory systems require a communication network to connect inter-processor memory. Processors have their own local memory because uh, because each processor has its own local memory. It operates independently. Hence, the concept of cache coherency does not apply. When a processor needs access to data in another processor, it is usually the task of the programmer to explicitly define how and when data is communicated. Synchronization between tasks is likewise the programmer's responsibility. The main fields that need advanced computing are computational fluid dynamics, design of large structures, computational physics and chemistry, climate modeling, vehicle simulation, image processing, signal processing, oil reservoir management, semistic data processing. India's contribution towards parallel computing. India has made significant strides in developing high performance parallel computers. Major Indian parallel computing projects: Param, Anupam, MTPPS, Space, Chips, Flowsover. Thank you.